All right, so we're starting off into the 3-5 notes. Again, these are word problems which require the use of inequality symbols in your setup. All right, example number 2, we got Elvira's cafeteria. All right, she's got these cute little milk cartons. All right, the milk supplier charges 35 cents per carton of milk in addition to a delivery charge of $75. What is the maximum number of cartons that Elvira can buy if she budgeted $500 for milk? All right, so again, we're going to define our variable. In this case, we're going to let x represent, all right, what we're looking for, the maximum number milk cartons. All right, so number of milk cartons, defining our variable. All right, so now we need to write an inequality. Again, we know we're going to be using inequality because we're looking for wording that says so. And again, when we see words like maximum, right? So again, so there's a range of values at work here. So we've got a maximum budget of $500. Okay, so we know we're going to be doing something with that 500. So if it's a maximum budget, meaning we cannot go over budget. So that means we need whatever we spend for milk has to be less than or equal to that 500 budget. All right, we cannot go over, right? We can't put a greater than symbol in there because again, we can't spend more than what we have in our budget. All right, so let's see if you can figure out the expression that's on the left of this inequality. What should we write, which again expresses what's happening here with the buying of the milk cartons? All right, so the left side of this inequality is going to represent what we're spending for the milk. All right, so there's that $75 delivery charge. So we're going to add that to what we're actually paying for the milk. So again, per carton of milk, it's 35 cents, so 0.35. And we're going to multiply that by the number of milk cartons that we order. All right, so again, the expression on the left represents what we're spending, which is the $75 delivery charge plus the 35 cents times the number of cartons of milk that we order. All right, so when we solve for x, using the help of our calculator, we get this decimal approximation. Now, we got to be careful. Again, we talked about with these word problems that you need to write a summary sentence. All right, so you don't want to end this problem by circling x is less than or equal to this decimal. All right, so again, we got to think about what x represents here. Right? X represents the number of milk cartons that we're going to order. And we cannot say Elvira needs to order 1,214.2857 cartons of milk. Right, so we definitely have to round. So which way do you think we need to round and what our summary sentence should sound like? All right, so now normal rounding rules say that we should round that decimal down to 1,214, right? Because that 0.2 number says that, hey, we got to round down. Now, that is what we need to do here because, as you see through my summary sentence, it says to fit her budget, Elvira can buy a maximum of 1,214 cartons of milk. Right, so again, we have to include that word maximum, right? Because we're not talking about Elvira buying exactly 1,214 cartons of milk, right? So we can say she can buy up to, right, 1,214 cartons of milk. She can buy less if she wanted to, because our inequality says as long as she doesn't go over 1,214 cartons of milk, she should be able to fit her budget. All right, example number 3. So we have here students love ranch dressing. So Elvira needs to make sure she has enough in stock. All right, so she figures that students eat about 2.25 gallons of ranch each day. Elvira started the school year with 130 gallons of ranch dressing. She needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. So we need to figure out how many days will her ranch dressing supply last before she needs to reorder. Okay, so we're going to let X represent the days of having ranch dressing. So again, we need to write an inequality because again, we see wording that says there has to be an inequality, and we are focusing on this word at least. All right, so again, we're comparing, right, the amount of ranch dressing that she has on hand. So for this, she wants to have at least 20 gallons left. All right, so we're going to compare the amount of dressing that we do have or that was consumed versus what is left on hand. So what inequality symbol do you think we should put right next to this value of 20? Okay, so again, we do not want to run out of ranch dressing. Right? Nobody wants to run out of ranch dressing. All right, so we don't want to go below that, right? She wants to have 20 gallons, right, minimum left over. So here we have greater than or equal to. So we want our supply of ranch dressing to not go below 20 gallons, okay? All right, so we need to figure out an expression that represents, hey, how much ranch dressing was consumed. Well, again, we started off with 130 gallons of ranch dressing at the beginning of the school year, right? And if students are consuming 2.25 gallons of ranch each day, so that's the consumption, so that means, hey, that our 130 gallon supply we started off with is going to shrink. So we're going to subtract, and what we subtract by is going to be, right, that 2.25 gallons per day times the number of days that, right, these students are eating ranch dressing. Okay, so there's our inequality, right, which represents the supply of ranch dressing on hand, right? We're going to start off with our 130 gallons. We're going to subtract off the consumed amount, right? So that's going to, again, what's on the left represents, hey, what we have on hand, right? We want to compare that to 20 and what we have in stock. We don't want it to go below 20. So that's why we have the greater than or equal to symbol. All right, let's go ahead and solve that. All right, so when we solve for x here in this inequality, right, and during the process of solving for x, we got to flip the inequality. So now, with the help of our calculator, we get x is less than or equal to 48.888 repeating. All right, so now again, we need to round that accordingly. So now we need to be careful where we round. Now again, normal rounding rules say that with that 48.888 repeating, we are supposed to round that to 49, right? However, right, if we round this to 49 and our summary sentence says that, hey, Elvira can go up to 49 days, right? Now, because of the less than or equal to, we talked about, hey, if we plug in 49 in for x, you're going to find that we are definitely not going to satisfy our inequality, right? 49 will make that inequality untrue, right? So therefore, we need to go against normal rounding rules, and we need to take that 48.888 repeating, and we need to round down, okay? So our summary sentence should read, Elvira can go up to 48 days before she needs to order more ranch. All right, so once she gets to day 48, she's got to order more. Right? All right, so here we have Elvira. She's got to order veggie burgers. So she ordered veggie burgers 4 different times, paid $78, $72, $87, and $90 respectively for those 4 orders. Again, to stay within her budget, she needs to make sure that her average order for the veggie burgers is not more than $82. how much can she spend on the 5th order to keep the average order within her budget. All right, so again, right, we see this wording here, not more than $82. So that's an inequality. So we want to compare her, what she's averaging on her orders, to this 82 value. Again, we cannot be any more than that. All right, so therefore we need to put our inequality as less than or equal to. Okay. All right, so again, we see the word average. So again, we think about what we did in the last unit in terms of writing an equation for average. All right, so that means we are adding our orders that we have plus that 5th order of X, and we're dividing it by 5. All right, so here's an expression which represents, hey, the average for the 5 orders that Elvira was going to be making for these veggie burgers, and we need that average to be no more than 82. So that has to be less than or equal to 82. All right, when we solve for X, we get X is less than or equal to 83. So our summary says that 5th order can cost no more than $83. All right, so again, if we want to stay within our average budget of $82 per order, that 5th order can cost no more than $83. All right, so here Elvira's got these ready-made pizzas for $14.50 each. If she makes them in the cafeteria, she spends $44.20 on ingredients and $6.25 per pizza on labor. All right, so we need to figure out how many pizzas is it cheaper for the cafeteria to make the pizza themselves rather than to buy them ready-made. Okay, so let's see if you can figure out an inequality, right, that goes with number 5. All right, so here's our inequality. So on the left, we have an expression that represents the cost it would be, what the cost would be for making the pizzas themselves. So you have the $44.20 for the ingredients, and then the $6.25 per pizza. Right, so we're going to multiply by X. That's for the labor. Okay, so on the left, this expression represents the cost for making the pizzas themselves, and on the right, we have the ready-made pizzas. Obviously, there's no labor cost there, so it's going to be $14.50 each. So $14.50 times X, the number of pizzas. All right, so again, we're going to be using the less than or equal to symbol here. And actually, we want to use the less than symbol. Let me change that up. All right, so we want to use the less than symbol here because we definitely want the cost for the pizzas to be cheaper on the making themselves side, right? All right, so here we go. So less than 14.50x. All right, so solving for x, we get x is greater than 5.357575. So again, we need to round that appropriately. So again, we're trying to figure out how many pizzas they would need to make for it to be cheaper, right, than buying the ready-made pizzas. Okay, so we're going to round this up to 6. Right, because if we round this down to 5, again, we follow normal rounding rules. Right, if we round this down to 5, right, then it would not work for our inequality. Okay, so if they made 6 or more pizzas, the cost would be cheaper than buying the ready-made. All right, we're going to have to go to a second video here, so move on to video lesson number 2.